This conference will now be recorded.
Okay, thank you all. Thank you for joining this session. And so today for the next 30-40 minutes, I'll share my the point of view or the way we are looking into the trends when it comes to the performance testing and engineering. I'm Satish. I have close to 12-13 years of experience both in performance testing, engineering, and development. So I guess most of us who have joined this call or might be having a performance testing background, probably just beginning your performance testing career, or some of you might be test leads, test managers. Guys, you able to hear me?
Yes, I can hear you.
Yeah.
Okay.
Yes, I can hear you.
Okay, thank you guys. So which means you might have been already doing certain things when it comes to performance testing, right? Basically your requirements, non-functional requirements, workload analysis or scripting or execution analysis, all these things you might be doing it as part of your current role. You might be doing everything together, or you might be doing only scripting or only execution depending upon your experience and depending upon the role you're playing in your project. Okay, so when it comes to trends, when it comes to what do we see in the market today, one from the expectation of the projects or the happening in the second, more from the way the expectations from new jobs or new career. So what are the next? So you are currently doing performance testing, all good. You do know JMeter, load runner, and then monitoring, basic level of engineering. All these things are you are doing it currently. So what is the next set of skill set that is something expected in the market as part of the trends? What we have seen so far in the last 1 year or 2 year, or in the 2021 and next year, right? What is it the projects will be expecting from you? That is what we wanted to probably share it across to this group, this audience, so that you can make yourself upskilled, or you make yourself aware of these things, so that we cannot just rely on these skills alone. Just being a performance tester, doing even though you're doing good scripting, good execution, good analysis, is that going to be enough? Okay, so there are 5 broader sections. What is something very trendy today, right? I will divide this into 3 parts. One is more from a technology perspective, more from an expansion of what you do today. The cloud and DevOps is more of a extension to what you do today. Cloud is more from the way the applications are developed and deployed in the cloud. So the application is not going to change, but more and more the applications are moving to cloud. And you as a performance tester or performance engineer, so you should be more aware of what is happening around the cloud area, and cloud-based performance testing or performance testing the application in the cloud, that becomes more and more important. And the DevOps, right? Performance automation or continuous testing or continuous performance evaluation in the agile, that is the another extension. So one, from a technology perspective, you would say cloud and DevOps is going to be more and more important for you to get upskill, or you should aware of what is happening within each of these streams. That is more from a technology perspective. Second is more of a different role, a site reliability engineering. So that is something separate role altogether that used to be earlier. There is an SRE role, more of an operational kind of a thing, right? Production extension of a production support, I would say, making sure your application is reliable, and then there are no problems in the production, continuously monitoring the production, and then evaluating or anticipating the problem in production. So that is something, a role used to be there, but now in most of the, now I would not say most, but in certain tier one organizations, they started to extend or probably merge this role into a performance testing or performance engineering, right? So the expectation is to one single person, a performance tester or a performance engineer, should also be able to play a site reliability engineer role. So that is something we would see what exactly is that, but that is the second category, SRE, more from a role perspective. Third is from something outside of our comfort zone, more into a broader knowledge. Okay, so we used to call this as a T-shaped skill set, right? You T-shaped, T will have a length and breadth, right? So T, if you see, you would have a deep knowledge, vertical knowledge, where your core strength would be performance testing or engineering. But it is also expected to have a breadth of knowledge where you might either you should know a development, or you should be good in other functionality testing, automation testing, or probably security testing, right? So multi-skill skilled person is more about SZ or full stack QA. Okay, so as I said, there are three things. One, more from a technology perspective, cloud and DevOps. Second is more from the within the performance itself, there's an extension to that called site reliability. Third is more from a full stack QA or this that expanding your knowledge outside of the performance. Okay, so three broad categories, and it's all depends upon your passion, your ability, where you want to expand yourself. All these five have the scope. Complete scope is there from a trend perspective, from a whatever we expect in the market. So all these five things are very much very hot skills, trendy one, depending upon your aspiration or passion towards cloud or DevOps or site reliability, or if you wanted to be more focused on development or probably a full stack QA. All these things are up for your grabbing. Okay, so let's go one by one, probably spend a couple of more minutes on each and every topics here. Okay, site reliability. So site reliability engineering, from the definition or the way your top tier companies look into this is, reliability is, we all know reliability is more towards the performance, obviously, whether your application is reliable or not, whether the site is up and running for 24/7, or making sure your end user doesn't get impacted, even though there is a problem with your server or from the database or any of your node, making sure your end user are not impacted. For that, there are multiple tenants inside reliability. One of the key things is going to be your resiliency. So you might have heard about resiliency engineering or chaos testing or chaos engineering. It's more about anticipating problem, creating chaos, and measuring how is your reliability is, how is your performance is. So normally during load testing or performance testing, right, we go and test your application, measure CPU memory, measure response time. If everything is okay, we say everything is good, right? We will say application is performing well. Okay, if there is a problem with CPU memory, we'll say the CPU is high, memory is high, and probably we'll try to find out the bottleneck. We'll try to do profiling and find out memory problem or CPU problem. But one more step into this is a resiliency, where we will artificially create these chaos. What happens if CPU is going to be 90%? What happens if memory is going to be very bad? What happens if there is a hard disk failure? What happens if there is going to be a network latency? What if chaos? So creating those chaos and then measuring your performance, measuring your reliability. That is all about resiliency. One of the key tenets within your reliability engineering. It's resiliency itself is a separate topic, a separate testing, or I would say engineering aspect, where be it as a cloud or non-cloud, resiliency is something very very picking up in the market, picking up in the customer's requirement, especially with AWS and Azure. They themselves have these chaos tools nowadays. AWS has recently, I think, introduced a new chaos technique or chaos tool, There is a one open source framework called Chaos Monkey from Netflix. All these things are Netflix being we all know Netflix is a video streaming video streaming app, right? But behind the scene, it has a very big IT unit, IT team, and resiliency. They do a lot of this resiliency engineering for various chaos. That is where the resiliency comes, and it is a part of your site reliability engineering. Other things are pretty much you might have already aware of it: end user experience, synthetic monitoring, real user monitoring. So in production, there are a couple of other synthetic monitoring, real user monitoring, end user experience, client side performance. All these things are part of your site reliability engineering. So I would say it is an extension of what we do today, more from a performance itself, but just that learning additional skill set, additional tools, so that you can call yourself a SRE, a site reliability engineer, an extension to your performance testing or performance engineering, what you do today. Okay, and the another normally in today's DevOps teams, in a small pod team, right? There is no cushion of having 3 testers or 5 testers or 10 testers, which is used to be earlier. Now for a small module, or for a set of microservices, or for a particular application, there will be a small set of testers. A tester, when I say, there will be maybe 2 developers, 2 testers, or 5 developers, 3 testers, and those 3 testers has to do all the testing for the application, right? Which means the expectation from the project team, or a QA person to have a multi skill. He should be able to do automation. He should be able to do security or performance to a certain level. I mean, of course, nobody can be an SME on all these things, but how can they cross function, right? Because at some times there will be a lot of automation testing has to be done. At some point of time, there will be a lot of performance testing has to be done. So which means we cannot have dedicated person, more dedicated person for all these spikes, right? So whenever there is a more work needed for automation testing, a performance tester should be able to pick up things and then able to support automation team, and vice versa. Which means a full stack QA is something also very catching up, and it has a lot of market value. If you know automation testing, if you know Selenium, it is always good to have. Your core is performance testing, but if you know Selenium, if you know automation, it is definitely a very good thing. Similarly, the vice versa also. So full stack QA, again, depending upon the project you are in, or probably in your company, depending upon the way you support multiple customers. If full stack QA is something you foresee, that is definitely a very good skill set to be for you to upskill yourself. Okay. Again, this is more from expanding your knowledge outside of your performance, but still that is something very attractive in today's market. The earlier one is more of an extension. You expand your performance knowledge, just not doing performance testing, JMeter, load runner. Beyond that, you would focus on end user experience, synthetic monitoring, real user monitoring, app monitoring, infra monitoring, and then the resiliency. So it's an extension to your performance testing. And full stack QA is the, as I said, it's expanding your knowledge outside of your performance. Similarly, SDET is, if you are good in programming, if you have a passion towards development, you can also, probably you're not going to do a full core application development, but how can you work with the development team to do unit testing using JUnits? So how can you contribute towards development, reviewing the code, and then doing involving deployments, integration. So if you're passionate towards development, and if you're good in any of the programming languages, so yeah, SDET is something. Again, you're not going to be, from SDET perspective, there are 2 things. A developer can do testing also. That is also called as a SDET. But now from our angle, if we can contribute towards a development team, nothing is like that. You can take the code, do the review from a performance perspective, involved in unit testing, right? So that is also something will be good. More and more team becomes agile, more and more teams became shorter. So your skill set, the development skill set, is going to really be very attractive one. So full stack QA or is that depends upon depending upon your current skill set, your passion. Both are up for grabbing. The other two are cloud and DevOps. DevOps, again, we're not going to be a DevOps engineer here. Okay, we are not going to go completely outside of performance and be a DevOps engineer. Idea is to how can you be upskilled yourself so that you can take care of your own performance testing in DevOps. Okay, so we use JMeter, we use LoadRunner, we use all the APM tools. How can you yourself can implement all this performance testing into DevOps? How can you work with a DevOps engineer to enable JMeter or LoadRunner or Performance Center or Dynatrace into the continuous testing and continuous monitoring? And then when you want to do it, you should be able to use AWS code pipeline or Azure DevOps, or you should be good in a couple of small scripting language like your shell scripting or Windows PowerShell or Groovy or Python. All these things are required for small automation. And you wanted to bring performance testing into DevOps, just not about running JMeter test there, right? You might need to write some custom logics, so to set some quality gates, to fail the job, to provide some reports. So where you would need some kind of an automations, small automation using PowerShells, shell scripts, like Groovy or Python. So you should be able to expand yourself, upskill yourself in these areas, so that you would be able to more and more contribute towards DevOps from a performance perspective. Okay, so that is something very much required in the market. So that is something you can that is something expected in the market, a trend we are seeing in the market, so you can upskill yourself towards that aspect. And then second is more into the cloud, right? When we say cloud, there are a couple of aspects into it. The application moves to cloud, there are cloud native applications and cloud migrations. So and obviously AWS, Azure, GCP, a lot of cloud providers are there, right? So you should be aware of what is happening in the cloud, who are the various cloud providers, and what are the various options available within the cloud for performance testing. What are the various monitoring tools available, be it is a Cloud Watch in AWS or Azure Monitor, right? What are the various APM tools that is supported in this cloud? And more specific to cloud, what kind of additional testing we may have to do it in terms of, so we all know that cloud is going to provide you missions on the go, and there is a myth saying performance is not required because cloud will take care of performance or scalability. Yes, cloud will take care of the cloud scalability. If one of the server is down or if the server is very performing bad, it can spin up additional missions, right? So scalability is taken care, but at the cost of you paying more money to AWS, right? So it's a trade-off between performance and your the amount you're going to pay back to the AWS. So it's more and more important to do additional testing to validate, benchmark, and optimize the server utilization. Okay, so scalability, though it comes along with your cloud, as a performance tester or engineer, we should make sure we optimize the usage. That is where the testing out the auto scaling options, making sure during auto scaling what is the impact of the performance. All these things we should be aware of how the cloud services works, and how are we going to test those additional scenarios. One, in terms of end user experience, when auto scale happens, your performance might be impacted. Okay, so we need to validate it, and or the VMs are properly configured, or the application is fine tuned so that there is no memory leak, there is no high response time, so that instead of two missions, if you have small memory leaks, or if you have performance response time issue, instead of just having two VMs, your cloud might be running with 5 VMs or 6 VMs to counter these performance problems, which means you're going to pay additional to the your cloud provider. So we should go and convince people, we should go and tell the project managers saying that performance testing is required, performance engineering is required, otherwise you need to go and pay additional money to your cloud providers. Right? So there's a lot of things, a lot of learning that needs to be done, a lot of exploration has to be there from a cloud perspective. Now, from you being just a performance tester, if you wanted to move towards cloud, that is absolutely very, very important, and there's a lot of scope and opportunity from a cloud perspective also. We can just say from a testing perspective, it's the same thing. If there is going to be an URL, you're going to do a scripting, you're going to do execution. Nothing changes from a pure scripting and execution. But beyond that, understanding the cloud landscape, and then your approach, your the way you're going to design your various scenarios when it comes to auto scaling, resiliency. All these things are, and from a monitoring perspective, there are different tools that is going to bring come into picture, and there is a also hybrid architecture that you need to understand whether how it is going to impact your performance. A database can be in a data center. Your application server could be in the cloud. In that scenario, what happens? So you should probably mimic those situations in your environment as well. And then accordingly, you have to go and design your approach, design your performance environment. So all these things are there. So just not about scripting execution. Beyond that, from a cloud perspective, there are a lot of things we need to learn and implement it. So putting it together, as I said, cloud and DevOps are going to be more from a extension to what we do today, taking performance into cloud, integrating performance into DevOps, two major area. SRE is extension of performance, and SJET and your full stack QA is something outside of our comfort zone, but more into expanding our knowledge into different skill set. Sorry, there was some question. Is somebody any question? Okay, fine. So to again to probably summarize it, right? There are two things. One, as you now exposed to this DevOps, cloud, SREs, and different things. So we should maintain two things. One, we should strengthen our basics. Our core is still going to be performance testing and engineering, right? So you should be strengthening your basics by probably understanding different protocols, expanding your knowledge in supporting different protocols, and then of course the performance engineering, fine-tuning, JVM benchmarkings, DB analysis, thread analysis, or heap analysis. All these things are going to be our core, right? So if you are a performance tester, obviously you should be strengthening your basics in testing and engineering, and then parallelly you should also expand your knowledge in these new areas, whatever that is expected in the market, whatever we have listed it. So that is how for us to be ready for getting new jobs or new career, or even in a current project, current company, current organization, you should always look to strengthen your basics in performance testing and engineering, and expand your knowledge in the new areas. And if you do it in parallel, I think that is where I think we will become more relevant to the current job market or current expectation in the your projects. When I say again the testing and engineering, right? This is a very high level view of various activity that as an engineer you will do, right? There's a difference between being a performance tester and engineer, right? Most of you might have experienced it. If you're a tester, you might be fitting into your SDLC maybe at the end of your project, right? If it's going to be a 6-month project, you might be called in maybe after 3rd month, or maybe at the beginning of the 4th month, for you to go and start the scripting and do the execution. It is very shortened time period. As a tester, you do scripting execution, and most of the time they might even come in the 5th month or 3 weeks before the release and ask us to do the execution. That's how most of the projects are. Okay. But when it comes to engineering, it is just not scripting and execution. It is more towards your architecture more towards designing, more towards profiling, working along with the developer to optimize the code, which means you would have a larger role right from your development cycle till the code moves to production. And even in the production, you might need to do the continuous testing and continuous monitoring, continuous analysis. So the scope of your work, your relevancy of you in a project lifecycle becomes more and more when it compared to performance tester. So that is why we say strengthen your basics, just not testing. It's more about engineering as well. So which means if there are going to be 2 performance tester or 3 performance tester who will be onboarded maybe at the 4th month or 5th month, if you are going to be a performance engineer, you would be there for more than 3 months or 4 months. For example, I'm saying in a 6-month project. So your relevancy become more and more important. Your role will be more expanded, so you will feel more relevant in your any of your project. And while you do that, you always can go and expand your knowledge in the other areas, so that you can always be expand your skills, and also be ready for any other if your project might be moved to cloud, your project might move to DevOps, your project management might look you to do some SRE roles, or they might expect you to do multiple other testings, right? It can be anything. I mean, obviously you cannot go and do all these things, but whichever you think that you anticipate in your project, in your enterprise, or whichever you are passionate towards, that you can probably pick one at a time, and then you can expand your knowledge. That is how we see the career of a performance tester can grow beyond a normal testing towards engineering, and also all these additional skill set. Okay. I'll just take a pause here. If there are any questions, we can probably discuss. If you have anything to probably, if you have anything else to share, you can also share your.
Hi Satish, Arun from this side. Satish, can you hear me?
Yeah, I can hear it. Go ahead.
Okay. Satish, just it's a very simple and quick question. Is that just see whatever the environment we are just doing previously, but right now everybody are telling about cloud. If you want to make a 1 to 2 sentence difference, then how can you differentiate between these two? Means what exactly is the critical difference on that?
Critical difference on what? Cloud
yeah, cloud and what are the environment we are just getting on the premises, means customer premises we are just doing previously, means 3 to 4 years back.
Okay. See, the one major thing is now the application being in the cloud, there are 2 things which will go away. One is the see, earlier we need to go and estimate our load generators, and then we will tell we need 5 load generators, 10 load generators, and we need to go and procure it. Now with cloud, that is one of the advantages. They can be provisioned on demand. Okay, so that is something that's going to change. So load generator, as much as you need, you can just use it for that time period, and it can be disconnected or terminated. Similarly, for the environment also, say if you need 5 servers, 10 servers, similar to production, earlier they used to get 50% of production environment, right? Only 2 servers or 4 servers, because it is all going to be cost. Now with the cloud, you don't need to have a problem. You can get a environment that is similar to production. You can just use it for 10 days, 5 days, and those can be decommissioned, because that's how the cloud works, right? You can get the machines on demand, and you can just go and terminate it. You pay only for that time limit. Those are the from the infra perspective. Second, from the our approach perspective, the scripting and execution is not going to be, nothing is going to change a lot, but the tools, the monitoring tools, right? The AWS has CloudWatch, Azure has its own Azure Monitor, and so we will be instead of using Perfmon, instead of using your VMstat tools in Linux, right? Now we more and more will be using the tools provided by the cloud, because they are the one who take care of infra. So they provide this CloudWatch and other Azure Monitor to which will natively provide these default OS level metrics. Okay, and again from a cloud, as I said, scalability, cloud is going to provide you, right? So which means it's going to have all these auto scaling functionalities. Whenever there is a hardware failure or there is a more traffic, it is going to spin up more additional missions. So we may need to include additional scenarios, additional testing to validate these auto scaling kind of features. That is how it is going to differ from a traditional versus the cloud way of doing it.
Means you are just so this means you are just trying to say that before that we are just going to estimate everything, but when you are just going to enter on cloud basis, that time we are just we are just getting all those systems from there, and we are just not depend on others. It means total based upon environment details that you are trying to say, right? Sudhir?
Now with the cloud, we don't need to go and reserve it. We don't need to go and probably estimate it 3 months back, 6 months back. Somebody has to set up your environment and then give it. Now everything can be provision on demand. You just ask, they will give it in 2 days, 3 days, and you can deploy the code. You can use it for testing, and then they can just go and decommission it. Okay, it's all images. So setting up the software, setting up all the required dependency in the mission, it's all going to be very fast. Right, your cloud infra team will take care of all these things, so you can get your production like performance environment within a couple of days.
Okay, Satish, thank you.
Hey Satish, hey Anup here.
Yeah.
Can you tell me, means in early performance testing, or we can say a shift left approach? Okay, in that, how we can measure the scalability of the any servers or something? Like now it is a DevOps, so we can't go directly to the production with the all big bang approach like that. We are going in a step by step or something. So how we can find out that this much of environment is okay, or how we can scale it? Like there are approaches like vertical and horizontal scaling, but I don't know, means how we can do it.
Okay,
So we can scale early.
so you're talking about shift left and you're talking about scalability. So I didn't get that question properly.
In early performance testing, how we can scale, how we can do the scalability? That's the question.
Okay, see, definitely not, right? Early performance and doing the scaling will not go hand in hand. When you say early performance testing, it could be a single user performance or single user profiling or running it for a low volume test. Correct. I'm using either you can use a Selenium script for small volume test or a single user test. So all these things are early performance. Maybe for microservices or for APIs, since it's going to be API testing, a lot of early testing can be done at a full scale. Okay, just go and run all your get calls, scripting your get calls using JMeter is not going to take time. So you can just spin up permissions and you can run, right? But for your normal web shift left early performance, yeah, we don't recommend to do the full scale load testing in your as part of the early performance. It has to be happening in a traditional way.
Okay, but
See, end of the day, when you say
what will be in the DevOps approach? Means there is a models are going deployed.
It is a build-to-build comparison, right? You are going to say in a shift left early performance, you're going to run some 500 user test. It's always going to be 500 user test. So always you're going to compare with the app to app.
We need to add multiple servers in that, or any means configuration we need to increase. Servers means now only the login part is going on. After that, some bigger part is going on. So that time we need a extra resources or something. Like, are you getting my point? So how we can manage it in this particular thing in DevOps?
See, when an application is incrementally built, and if you're going to run these kind of test, right? There is no single answer to it. Okay, there is no single approach to it as well. It all depends upon kind of application you have, kind of scripts you're going to have, kind of environment you're going to have. So we always going to have a regression suite, right? So you said the login is already available. So always you're going to validate your regression suite. There is always going to be, say, 500 user. So 500 user test, you're going to run it. for your already completed functionality regression suite. That is going to be one validation. For a new deployment, making sure your existing functionalities are tested. That is a regression that you always do with a find user test every time. And for the new functionalities which are going to be introduced in the current sprint, it is not going to be part of your pipeline, right? You're going to individually test it, individually profile it, and then create script for that, and then benchmark it, and that will be added to your regression suite. So when you add this to regression suite, then probably instead of 500 user, it might be now you are introducing new functionality, so which means there will be additional TPS. Then you will take one benchmark including this new functionality, and you might be deploying it for as part of the next regression suite. But the new functionality, is it going to increase your memory footprint, CPU footprint? Yeah, it may be. So it is more of a engineering decision where in the DevOps, whether you're going to from 4 GB RAM, 4 GB heap, or you're going to increase it to 6 GB heap or not. Individually, you will benchmark those things, and then you decide that, okay, from next regression, we are introducing new functionalities which will require additional heap or additional thread. So you benchmark it and then bring that into a regression. So it is not a direct answer. Regression is going to be there for the existing functionality. When you're going to bring in new functionalities, you need to individually, outside of a pipeline, you need to fine tune it, optimize it, and then depending upon the footprint for those functionalities, you will then go and increase your JVM configuration after benchmarking.
Okay.
Yeah.
Hi, sir.
Yeah.
Hi, sir. Can you hear me?
Go on.
Yes, go ahead.
So my question is regarding like performance engineering perspective. So as you said, there will be many in-house tool monitoring, right? From when the application is deployed in the cloud. So does it mean the APM tool that we have, it is going to provide the same engineering metrics in the cloud, which is available for Azure or AWS?
There will be overlap. There might be a few uniqueness. So architects, performance engineer together will have to design the monitoring tool for those things. For example, if there are going to be cloud services which are going to part of your architecture, okay, maybe it is going to be a Elasticsearch or a MongoDB, or it could be Lambda functions, and those native services which you get it from the cloud as part of the architecture, definitely I think it is good to use the native monitoring that is available. And your core application could be a Java application or a .NET application or Node.js, right? And the APM tool like Dynatrace or AppDynamics might be doing a very good job when it comes to these engineering aspect. It is going to be a combination of tools that whichever we think is going to be good for certain area, we will use cloud tools. Wherever we feel APM tools like Dynatrace is going to be good, we'll go and choose these APM tools. So most of the places, we have seen both. A combination of both cloud monitoring tools plus the APM tool is the, especially when you migrate your data center application to cloud, right? You might be already having this APM tool for your application. Just that your application is going to deploy in a cloud. In that manner, it is going to be combination. If it is going to be pure cloud native application, you're going to create some microservices in the cloud from scratch. We have seen that the team tend to use complete cloud monitoring tools and not go with these Dynatrace or AppDynamics tools. So it is going to be, we need to decide whether the tools are going to give complete visibility into the performance. And accordingly, you can mix and match and pick whatever that is required. Decision taken by both architects as well as the performance engineer. You might have 10 components in your architecture. Whether the tools that is there in the cloud is going to give visibility to all 10 components, all the tiers. If not, then we may have to go to a blended approach.
Okay, great. Yeah. I mean, there is definitely a dependency from both the sides, the in-house tool from the particular vendor and also the APM tools.
Exactly. There might be a product you might be purchasing. Say, I'm just saying an SAP maybe. SAP might be having a native monitoring tool which will give a lot of insight that which cannot be given by your cloud tools. So a cloud tool can definitely give a infra level, network level, because they are the host. They will give you a lot of visibility on infra and network for sure. But application level diagnostics, whether will it can be give it out of box, may not be for all the application.
Yes, yeah. And I mean, in general, there is one more question for the client-side metrics that we'll be measuring, right? I mean, always we'll be measuring the server-side metrics. So client-side metrics, we are measuring for giving the true visibility, right? End user experience. So
Correct.
how the APM tool is going to measure it? Because I don't have much idea on the engineering part as far as APM tool is considered. So is it going to add certain value to the response time, or is it going to mimic the browser? Or how is it happening?
So there is a APM tool. There's a real user monitoring where it can monitor the real user browsers. You and me accessing say Amazon.com. There will be cookies, JavaScript that will be running in our desktops, our mobile, which will send this data. There is a real user monitoring, and few tools also have the capability to run um, uh, monitor the data when, say for example, when you go to run some Selenium scripts, right? In your pre-production environment by automation team. You can also, there are Dynatrace headers that can be added to the Selenium script, which can actually collect these data. So mostly the APM tools will rely on real user monitoring capability to provide the end user experience. And Dynatrace also have these synthetic monitoring, where you can also create UI based scripts. Okay, and those UI based scripts can provide you the end user experience. Since it is going to actually mimic a Chrome, execute it over the Chrome, it can provide you the end user experience. So combination of synthetic monitoring tool plus real user monitoring, you would be able to achieve this client side performance or client side validation.
Okay, got it. I mean, basically, why I mean, I got more into this was because when we go for a performance test, load user test, right? Suppose 10,000 users. So if we do a GUI based load test, then it will be kind of opening 10,000 user sessions in Chrome or Mozilla. So the footprint is
Now,
going to be very high, right?
normally it will be combination of say 10,000 user plus 2 or 3 browser based user, because you're going to measure the end user experience when your servers are under load. Correct.
Yes.
So which means you don't need to do 10,000 user browser load test. You just need to run 10,000 regular load testing plus 1 or 2 real user testing, and so that you will be able to measure the end user experience when the servers are loaded.
Okay, so that capability is there in the APM tools. That
Not in
extra
the
tool.
APM tool. That capability will has to be brought in by running some Selenium scripts along with your JMeter or along with your load runner. That is nothing to do with the APM tool. It is, yeah, APM tool also can do it in such a way that it's synthetic monitoring capability. If you can extend it, right, to pre-production, you can create UI based script in synthetic monitoring component in Dynatrace or AppDynamics, and you can schedule it to run for 1 hour, 2 hour, for every 5 minutes along with your load test. That will provide you the end user experience. That is also an option.
Okay, great. Thank you.
No problem.
So there's one question. Performance trends. How important to learn about this virtual mix? I mean, this containers and all these things that are coming up.
See, there are two view into it, right? One, applications are deployed, applications run as a Docker, a container. Services, microservices run inside containers. So definitely, when you wanted to expand your knowledge to a cloud, it is also good to know about Kubernetes monitoring, container monitoring, concept of all these containers, Dockers, images, Kubernetes, or definitely it is going to be good. It is good to do, and you might end up in a project where It's a cloud-based application. Deployments are done through Kubernetes. So it is definitely good to get that knowledge. Second aspect is even JMeter and load runner as a software can be run as a container to bring in more efficiency, to bring in some kind of maintainability, right? Load runner also have a Dockerized way of running the load generators. JMeter has Docker images running as a container. So if you want to run your load runner scripts or JMeter script inside a container, that is also something. There are projects where people are expecting to do that. So in both the way, I think understanding the AWS or Azure way of creating images and creating containers, it is going to be definitely useful.
So do you mean to say that when your applications are more moving towards the cloud, that is a point of time this will be used, like Dockers and containers?
Yeah, absolutely. Yes. When team has decided to move towards cloud, one from a deployment perspective, second is more using the cloud services. So just moving the machine from data center to cloud, you're just going to rent out machines and you're going to deploy it. That is a one aspect of cloud. Second is cloud providers, they have a lot of these services running as a containers, and then they have a lot of other services like Kubernetes or ECS, container services, lambdas, auto scaling. All these are cloud specific services which you may have to learn as you make this. If at all you see that your project team are moving towards cloud.
All right. Sorry, might be a dumb question, but as because I don't have much exposure towards it, when you see when you tell about the different kind of services to be opt for, right? So do you see that when we are moving towards cloud, this is mandatory, or without that also things can be taken care of? I just wanted to understand that where it will
That
play a major.
yeah, I said there are two things. One, you just like you rent the rent something from other people, right? Cloud AWS provides you mission more from an on-demand basis. They just rent out the missions. They have these VMs, big boxes somewhere in their data center, and they just rent out this VM for you and me or for big companies. So without using any other cloud services, you can just make use of those on-demand option. When instead of me maintaining my infra, I don't want to maintain my infra in my data center. There's a lot of overhead. I have now my application. I just go to AWS, ask AWS to host my application. They will just deploy 5-6 missions on demand. You can go and deploy the application. You just can use that infra alone from a cloud perspective. That is one. Number two, along with that, they provide you a lot of other services, right? That is where the other services like your Lambda services or these container services, and then the CloudWatch, all these things are again licensed payable services. As you wanted to become modern, as you wanted to make your application more flexible, faster development, rather than you go and do everything from scratch, you can use the templates, you can make use of the ready-made services that is available in the cloud.
All right, thank you.
Yeah. Fine. And more towards, yeah, please go ahead. Someone has any question?
Yeah. Hi, Satish. This is Puneet here. See, this course is completely focused on testers, or because I'm from a cloud background. So how this will help me?
Okay, so I mean, this is not a course. Actually, this is more of a webinar or more of a point of view we wanted to share. This is not a course. This is just a session on sharing our experience and knowledge. This is not a course. First thing. Second, of course, we have certain courses tailored for, say, engineering, tailored for site reliability engineering, and for full stack QA. There are individual for cloud, for DevOps. So we have separate courses available for all these things, but everything will be focused on performance testing, whatever we've spoken about today. So if you are part of a cloud practitioner practice, and if you're looking for something on performance, there are courses available, but nothing very specifically to the cloud itself. So Isha being a performance testing organization, performance oriented learning organization, all these things are available as separate courses. Performance engineering is a course, there's a course completely covering the engineering aspect, and we have course for site reliability, and then for full stack QA or DevOps or cloud. We have individual courses, Puneet.
Okay, so my primary focus was actually AppDynamics, because in my company they are extensively using this, for APMs. So that was my primary focus. So you're just
Okay.
giving a general perspective here, correct?
Yeah. This today's topic is just providing a general point of view on what is something trending in the market, more from an awareness perspective. But there are courses, say for example, we have an engineering course where AppDynamics is also part of it, or we have an exclusive course for AppDynamics itself. Isha has that, and then most of the thing, whatever we are speaking, there are individual courses available. For your case, if AppDynamics is what you're looking for, there are two options. One in the performance engineering, we cover AppDynamics, and we also have a dedicated AppDynamics course as well.
Okay, got it. Thank you.
Yeah, Pradeep.
Hey, Satish.
Okay.
Hello. Hey, Satish.
Yeah, please.
Hello. Hey, Satish, in future, maybe I'm expecting any DevOps plus cloud-based performance testing, any course available in Isha. I mean, I will elaborate more because in DevOps is a big subject, AWS is a big subject. As a performance tester, as a performance engineer, how much it's our job, related. I mean, our job is out of a DevOps 10% or 20%. Like that, AWS also 10%, 20%. This will cover any course is available in Isha. This
Yeah,
thing. I
it is
understand.
available. Yeah, I got it. It is available. Okay, it is available. Just ping Kumar, sir, or ping me. We will provide you the required information. It is there. To answer the question, yes, it is there.
In both DevOps plus only one
Yeah.
course, DevOps plus AWS.
Yes, it is there. It is there. Yeah, it's there.
Okay. Maybe in any, maybe we'll chat personally. I will ping you my course details.
Sure.
Thank you.
Definitely. Yeah. Okay then. Thank you. Fine, guys. We just have a couple of minutes left. So, if you have any similar to the question he asked, if you have any questions on the individual courses for engineering or for the other aspect, just ping us or reach out to Isha, reach out to Kumar sir. They will be able to help you out with the course. This session is more towards the bringing in the required awareness, and then just sharing the point of view on the trend what we see in the today's market, guys. So thanks a lot for taking your time. Being weekday, evening or morning your time. Thanks a lot for your time, and thanks, guys.
Hey, thanks, Satish.
Sorry to interrupt, Jinsla here. I just think
Thank you.
questions. It could be a quick one. Hello.
Yeah. Sure. See, when it comes to microservices or APIs, from a scripting perspective, execution perspective, there's nothing changed. But more from benchmarking perspective, depending upon the way the microservices are going to work, right? And most of the time, it is going to be a separate entity. Every service can work on its own. Every service will have a separate node or separate JVM in which it is going to run. Depending upon that, your approach might be changing. You might need to benchmark at a service level, at a component level, not at the end-to-end level. Maybe earlier with the APIs, every APIs will be part of a one WAR file, and you need to test all the APIs together. But with microservices, that might change. Every service might be deployed in a separate WAR file or separate port. It will be separately running in a pod, which means you may have to benchmark every microservice separately. That is a key difference, Jishila.
Thanks, Satish. And one more question regarding the performance of cloud platform, where we have GCP, Azure, and AWS. In terms of performance, which one would be better? It's not from load simulation perspective, it's from application perspective. From your
You're
experience,
asking,
you can tell us.
you're asking this better?
Yes, yes,
No,
yes.
all our cloud providers. It all boils down to every cloud provider is going to have a missions 4 GB, 8 GB, 16 GB, 32 GB, or dual core, quad core. So from a cloud provider perspective, there is no relevancy with respect to performance. It's all about the application which is going to get deployed, the way you're going to utilize the cloud services efficiently. It boils down to you and me how we are going to develop and deploy it. So nothing to do with AWS or GCP or Azure that is going to decide your performance.
Okay, got it. Thank you.
Yeah. Fine, guys. Thanks for your interactive session. Thank you, guys.
Thanks, Satish. Bye.
Yeah, bye bye.